The title of the talk is the ichthyofauna of Zululand estuaries, some preliminary results. So I'm just going to tell you of some of the work that we've been doing at the University of Zululand in the last couple of years. Okay, so estuaries provide nutrient-rich waters, enclosed areas and warm waters, which provides important nursing areas for many marine and estuarine fish species. There are approximately 160 species in South Africa that are associated with estuaries, and of these, about 60% are dependent on these systems for completion of their life cycles. Also, 50% of the 160 are also utilized in either subsistential, recreational, or commercial fisheries and contribute to about 1.2 billion rand per year to inshore fisheries. Now, as mentioned, the most important fisheries in terms of fish biodiversity in South Africa all occur along the north coast of KZN, with Lake St. Lucia, Cozy Bay, Richards Bay Harbour, Umshatuzi Estuary, Umlamlazi Estuary, Amatikulu-Nyoni Estuary, and Durban Bay taking the top spots on this list. Now, many of these systems have been affected by anthropogenic activities, which include coastline urbanization, dredge sediment fisheries and agriculture, flow changes, intertidal loss, eutrophication, oxygen depletion, port development, and water pollution. Also, information on these fish communities of Zululand is also limited and or outdated. So we've been working on these 6 systems, and they are arranged according to their importance in fish biodiversity. I've also listed the type of estuary, their overall biodiversity rank in South Africa, as well as their current estuarine health category. So just pictures of these estuaries. So sampling was done in these systems. Apart from Richards Bay Harbour, they are protected to some degree. And we sampled between 4 and 9 sites, depending on the size of the system. 3 methods were used for sampling: small seines, large seines, and beam trawls. Sampling was conducted biannually for winter and summer samples. And all fish collected were ID'd, measured, and then released. And catches per unit effort were calculated as number of individuals caught per meter of area sampled per hole. So I'm going to show results for each of the systems in turn, and all the CPUE values that are given as fish per 10 square meters. I'm also dividing it into 4 groups according to estuarine association, which are color-coded in all the figures and tables. And these groups are the estuarine breeding species, the freshwater species, the marine species that are dependent on these systems for completion of their life cycle, as well as marine stranglers, which are marine species that enter the systems but are not dependent on them. So the first system is Lake St. Lucia, which was sampled over 4 years. During this time, the St. Lucia mouth was closed, obviously, but the beach channel connecting it to the ocean by the Mfolozi was quite active during 2012-2013. A total of 58 species were recorded over the 4 years, ranging from 29 to 34 per sampling season. Now, according to Cyrus, the historical fish list for St. Lucia lists about 155 species occurring in the system. And also during 2006 to 2008, the VA et al. Studied the system, and that was the time in November 2007, which was after the mouth was opened by storm activities caused by Cyclone Gamide, that the highest number of species in a single sampling trip was recorded over the last 10 years, which was 52 species. Now, Ambassus, which is a glassy, and Oreochromis mozambiquus tilapia dominated the system over the 4 years of this study. During the study by the VA et al., Oreochromis consisted 56% of the species, and the Ambassus species only 15%, compared to the current, well, for this system where Ambassus was 43 and Oreochromis 35. The average CPUE for the system was 21.1 fish per 10 meters square, and so I've done these pie charts with the main regions of the systems, the Narrow, South Lake, and North Lake, and there is a decline in species from the Narrows, which is at the mouth, to the North Lake, but there is an increase in the species abundance, with North Lake having almost twice the number of fish in terms of abundance than the other two regions. The Mfolozi system was sampled over similar periods, and the mouth was opened during most of that time, and a total of 62 species were recorded in the system from the seine nets and beam trawls. However, another 2 species were also recorded at gill nets, which was done at the time, bringing the total for the system up to 64. So historically, the Mfolozi system shared a mouth with the St. Lucia system, which means that it should have similar species in terms of their occurrence. Vivier et al. Also did a study on this system, 2007-2008, and they recorded 59 species at the time. So the mullet species, Caesar macrolepis, and then the glassies, Ambassus nataliensis, and Ambassus dominated this system over this period. The average CPUE was 7.8 fish, and when comparing the Mfolozi and the Msuduzi branches, we find that the Mfolozi had much higher species numbers, 59 compared to 34, as well as abundance almost triple that of the Msuduzi branch. Sampling in the Richards Bay Harbour was started this year. A total of 74 species were recorded. No freshwater species occurred in the system during these 2 trips, and a staggering amount, 28 marine stranglers, which is mostly due to the wide mouth and the large tidal exchange of the system. A quick survey was conducted in 2014, and they recorded 26 species, of which 5 were not recorded during 2016, bringing the total fish for the system up to 79. The last intensive survey of the system was conducted at the end of the 90s by crews, and they recorded a total of 127 species occurring in the harbour. The 3 Ambassus species completely dominated the system during 2016, making up about 85% of the fish catch. During the study at the end of the 90s, the 3 Ambassus species only accounted for about 17% of the catch, which means there's a large change in the last 20 years. At the time, the mullets, Lisa macrolepis, and Lisa demerida were the dominant species in the system. A study by Weirds, also at the end of the 90s, by just using small seines, recorded that mullets contributed more than 50% of the catch, while Ambassus was accountable for about 30%. Also, the average CPUE for the system during 2016 was found to be 29.5 fish per 10 square meters. The Mtutuzi system was sampled at the same time as the harbour. A total of 54 species were recorded during this year. In a review done by Weirds of the system since the construction of the harbour in 1997, recorded a total of 93 species for the system. Weirds also recorded 82 species during his study. Average CPUE for this system was 13 fish per 10 square meters, and the most abundant ones were Lisa macrolepis and Ambassus nataliensis. During the study by Weirds at the end of the 90s, he accounted that Rubbersaga species account for about almost 30% of the catch. However, during the current study, it accounted for about 11% in comparison. The Mlazi system, however, was only sampled once during 2013. 45 species were recorded at the time. Again, in a study done by crews at the end of the 80s, they recorded 88 species during that time. Dominant fish, again, Ambassus, this time Sumerili, and Euchnatus equili, which is the slimy. The average fish for this system was only 6 fish per 10 square meters. Last one, the Amatikulu-Nyoni, was also sampled during 2013. 51 species were recorded at the time. A study done by O'Brien et al. Recorded only 43 species. Sampling was done during 2005, 2006, and 2008. And during that study, they recorded 14 species that were not present during 2013, bringing the total for this system up to 65 in the last 10 years. The average CPU for this system was 7.3. Amatikulu system had slightly higher species numbers as well as abundance numbers than the Nyoni branch. In this, most dominant species in the system at the time was Rubbersaga saga as well as Cristella estuari, compared to the study by O'Brien where they found Ambassus and Bassus to completely dominate with 54%. So a total of 113 species were recorded in all the systems, consisting of 18 estuarine species, 5 freshwater species, 52 marine estuarine dependent species, and 38 marine stranglers. Richards Bay Harbour had both the highest species numbers as well as species abundance. And also when you look at the marine component, this was also the highest in the harbour in species numbers, but in terms of abundances, the Mshatuzi system had higher values. Now, when not considering the high amount of Ambassus found in Richards Bay, the abundances, which is these values here, are still significantly higher than all the other systems apart from the Mshatuzi system. Also, when excluding Richards Bay again and St. Lucia due to the mouth closure, the ratio between estuarine and marine fish was about 50-50 for the estuaries. So in this table, I'm trying to show two things. One, species that were common to all systems, which is the top group, and those that occurred in 5 of the 6 systems. These total to 39 species of the 113, and they accounted for more than 90% of the catch in each of the systems, making them the significant ones. So the estuaries were dominated by the marine estuarine dependent species, and this highlights the importance of these systems as nurseries for marine spawning fish and the continued need for their conservation and improved management. So the reduced species numbers relatively to historical records suggest that estuaries are under human-induced pressures with far-reaching consequences for regional marine fish stocks and estuarine conservation. So possible reasons for this decline could include industrial and residential development along the catchments, agricultural activities such as sugarcane farming in the estuarine functional zones, as well as freshwater deprivation, which alters the natural seasonability of the mouth. Poaching is also a large concern in most, if not all, of these systems, and there is no way that we can measure the effect that this is having on the fish communities of these systems, and potentially being an influencing factor that could gradually devastate the estuarine and associated fish marine stocks. As loss of juvenile marine fish in estuaries leads to reduced offshore populations, and this leads to a decline in fish recruitment back into these estuaries, and this forms a cycle that just continues to cause decline. Although heavily debated, climate change is expected to increasingly affect the distribution and abundance of estuarine and marine fish species worldwide. The impact on our estuarine fish stocks are still largely unknown, and the challenge is to distinguish the effect that global change is having compared to other variables in these systems. For example, increasing periods of drought in recent years has led to altered mouth dynamics of many systems, and leads to smaller river plumes, which acts as cues for many recruitment of marine fish, and thus also leads to a reduction in the recruitment of fish. Increased temperatures in estuaries may also lead to more favorable conditions for breeding, for example, estuarine breeding species that are occurring in the system throughout the year, such as Ambassus. Lastly, estuarine fish communities are regarded worldwide as sensitive indicators for habitat change in estuaries, because they tell us a story which we need to listen to that will allow us to better conserve and manage our critically important estuaries. I'd just like to leave off with 2 questions. Are we putting enough effort into unraveling the message in our fish communities, and are we doing enough to protect and conserve our estuaries? Thank you.